Chapter 4 is another brief chapter. It involves logic systems and theory in communication research. I only have 3 slides after this one, so I don't know how long this will take. Uh, there are 2 basic branches. There's deductive theory and then there's inductive theory. Now, let's review something we've talked about before. The word theory should not scare you away. It's not a very friendly word as it exists, so I suggest that you substitute in your brain every time you see the word theory the word explanation. So a deductive explanation sounds more friendly, I think, than a deductive theory. Theory should maybe have a beard on it and a really thick pair of glasses. It just seems very unapproachable. So let's look at theory construction in terms of deduction and try to remember this is all about explaining stuff. Here are the steps. The first is you need a topic. And I think in Chapter 2 there was an adequate discussion about how you should choose your topic. But you need to specify it and to get the right, not too narrow, not too broad, but just right in terms of your abilities to collect data. You want to specify the range of phenomena the theory addresses. So it may be just a local theory about the way things are in your hometown, or it could be a theory about a particular subset of population like young people, old people, rich people, poor people. The next step in this process is to identify and specify the major concepts and variables. A concept is more vague than a variable. So you can have a concept like hate or love is a major concept. And then how do you reduce that into a variable? So you might talk in terms of romantic acts that represent the concept of love. Love is an abstraction. We can't touch it, see it, smell it, but we know when it exists because we agree on certain aspects of it, certain dimensions that make up the concept. And we use variables, and we have to figure out which ones we're going to use to represent our abstract concept. Then the next step is to find out what we already know about these variables and how they relate to one another. So the relationships among those variables are derived from your search through the library and previous research in your area. And then you should come up with some basic propositions or what's known already from which you can logically reason that if it's true in the general sense, then it should be true in the very specific sense. As you move from the general to the specific, you're doing deduction. So if you know that all people lie or deceive others at some time in their life, that it's a universal trait that we all lie occasionally, or a lot, depending on the person, that if you go to a specific person and study their behavior, you will necessarily find them being deceptive in certain situations. So that's deduction. And that's how you build your theories. You start with a general idea and work forwards. In terms of theory and observation in the world of deduction, most of the time what we do is we take a particular piece of our theory or explanation and call that a hypothesis. So if the general theory is that, as in you may have studied in Com 210, cultivation analysis or cultivation theory, George Gertner and associates believed that the more time you spend in the television world, the more you come to believe that the real world is just like the one on the screen. And the people who don't watch much TV experience the world differently. They have different expectations. So that's the theory. A hypothesis would be people who watch more national news on television will report being more frightened at going out in public. Or people who watch a lot of primetime television will be less trusting of their fellow man. So that's a hypothesis that's related to the theory. And then the researcher's role is to go test those hypotheses. Well, if you say that people who watch a lot of TV will be more frightened or less trusting, let's put it to the test. Let's draw a sample of people and measure their amount of viewing and measure their distrust or measure their fear and see if there is a correlation between time spent and amount of fear or distrust. The hypothesis is not necessary, but most studies that have a lot of theory driving them do use them. In cases where you can't have a hypothesis, then you need to have at least a question. Whereas you take your hypothesis and move the verb and put a question mark at the end to turn it into a question. It's pretty much the same thought. But in the positive statement, it's a predicted empirical outcome. And remember, empirical means observed. A hypothesis must be falsifiable. So it's no fair finding, coming up with something that can't be disproven. That's so hypothetical that you cannot collect data on it. A good hypothesis must be at least be capable of being proved wrong. So for example, if your hypothesis was if only this Civil War general had won this battle, the Civil War would have ended completely differently and the North would be, they would have gone through Reconstruction. Such a hypothesis is just untestable because it happened in the past. There's really no way of knowing. We can only speculate about the past. A hypothesis typically predicts either a relationship or a difference. And I know this is a short chapter and I only have 3 slides, but this is a really important idea. When you look at your data before you collect it, you imagine your data coming in. You think about this potential data. Are you looking for a difference in one variable based on categories of another variable, like male, female? Do women talk more than men, or do old people use the cell phone less than young people? If it's a categorical difference, that's one way of framing a hypothesis, a difference. If, on the other hand, both of your variables can be quantified in a wide range of values, then you're looking for, does one go up as the other goes up, or does one go down as the other goes up? It's like the relationship between drinking and grades. Most people believe that the more a student drinks, the lower their grades. Or conversely, the higher their grades, the less interested they are in drinking because maybe if they're highly intelligent, they might know the risks involved with drinking, or they may have better self-esteem than someone who thinks that, I can't exist without friends and my friends all drink, therefore I must drink. A hypothesis can be directional or non-directional, and in the research literature we call that one-tailed or two-tailed, and the tails have to do with the normal curve. I know you've had Math 104, so you may remember that bell-shaped curve, and as the values trail off on the left and the right, those are the tails. And if you believe something is, if you make a non-directional hypothesis, the difference could be on either end of that range of values. So it's two-tailed. If you're saying it's more than, then you have to ignore the lower end of the scale and just look at the one tail of the distribution to see if your case can possibly support your hypothesis. A hypothesis directs how a variable will be operationalized. Again, short slideshow, a lot of really key terms in this chapter. Operationalization is simply taking a variable and breaking it down into a series of steps so that it can be measured. For example, flirting. Flirting is a form of communication. You're trying to communicate to a potential romantic partner that you're interested in them. But the mores and social patterns are such that you have to be careful about how obvious you are. So we all know what flirting is, but if we wanted to measure flirtatious behavior, how would we do that? We could think, well, what are the ways that for example, women flirt with men? Do they flip their hair with the back of their hand? Do they make a touch on the arm? Is that flirtatious behavior? Is wide-eyed, big smile, is that flirting? Guys, do they stand a certain way, walk a certain way when they want to be noticed by a female? Of course they do. But if you really want to measure flirtatious communication or flirting, you need to operationalize your variable. What do you mean by flirting? Well, I mean this, and this. And maybe two researchers will disagree. They may say it's all about eye contact and not so much the touching. Someone else may say, oh no, it's all about the touching and nothing to do with the eye contact. Or there may be a combination of variables that are put together. There may be a checklist of, if we see these 6 attributes of the variable, then we'll know that we have a strong case of flirting. If we only see 3 or 4 of them, we have partial flirting. And if we only see 1, well, very low or maybe negligible flirtatious behavior. You didn't know this would be so interesting to be a communication major, but some people do study flirting. Using inferential statistics, then, the null hypothesis presumes the opposite of what you want to find. If you're looking for a relationship between X and Y, you must first say there's no relationship. These two are unrelated. Or let's use a simpler example. Let's say that on some behavior, we'll call it X, well, let's just call it flirting, that men or women are different in the amount of flirting they do. If it was a one-tailed prediction, you'd say women are more flirtatious than men, or men are more flirtatious than women. If you wanted to be Switzerland neutral and you wanted to just make a non-directional hypothesis, you might expect to find differences, but the important thing to remember here is the null hypothesis is the opposite. So you would say no difference between men and women. Or if you're looking at relationships, no relationship between these two, these three, among these 4 variables. There's nothing there. And then when you collect your data and analyze it, your goal is to knock down the null hypothesis in order to find support. It's kind of a logical trick because it's difficult to prove a positive, but it's easy to disprove a negative. So if you just find a few cases where there is a difference or there is a relationship, then you have support for your real hypothesis. By the way, the real hypothesis is also called the alternate hypothesis or the research hypothesis. The null hypothesis is always called the null hypothesis, although it's not bad to memorize it as the hypothesis of no difference or no relationship. Deductive theory construction using qualitative research starts with the observation of a communication phenomenon until patterns emerge. So you might just go right to the bar to study flirting and sit down and just study people, strangers, relating to each other as they meet on the dance floor or at the bar or in groups of people. And just study the way they stand, the way they talk, the way they touch, the way they use their cell phone or smile. And you record every bit of communication phenomena going on there until you start to detect patterns. Like, well, I noticed that a lot of the women are doing this to attract the males, and a lot of the males are doing that to attract the females. Or you could do the same in a same-sex bar, where you have different people trying to attract each other. It doesn't have to be guys and girls. Usually the pattern is stated in the form of a rule rather than a hypothesis. So the researcher in qualitative research will say, if this event happens, then this will happen most of the time. This is the rule. Now, why is it not a hypothesis? Because the qualitative researchers have their own language and their own traditions and their own biases, just as quantitative researchers are also biased toward their way of doing things. So, different tribes speak different languages, different researchers use different words. A rule is very close to a hypothesis. But in qualitative research, these rules are tentative. You have to make additional observations to see if the rule is true. Validity means truth. Is it valid? Is it there or is it not? So the more observations you make, the more validity you have. Since rules define appropriateness, the researcher also observes to identify that the pattern is criticizable. So they have to be very introspective about, are they reading too much into it? Observations and then the refinement of rule statements keeps going in the same circle of you study it, you look at it again, you study it, you look at it again, until you reach the point of there's nothing else you can do, and that point is called saturation. And there's really no good definition for saturation except that you know when you're saturated. That concludes chapter 4.